All right, so we're at the red team overview and the introduction to what PWK is, right? Why we're going through it, and what you want to get out of it. Right, we're kind of gonna get out of the kiddie pool and go into a bit deeper of a lake or something like that. So, what are we gonna do? Right, what is PWK? Get an idea of what the requirements are to be able to find success in here. Get a feel for what the lab environment is, and get a feel for what these different exercises are that you'll find in your textbook and that we're going to map a lot of our time on the day to. We'll take a look at the labs, what's going to be required from you. And normally this is the time where we would go ahead and schedule our assessments, but we'll do that when we come back. And usually I suggest for people to schedule them maybe like a month out of program. So that way, you have time to digest this material and time to continue studying it, as well as something to kind of work towards once you're done with program and continue with the same, pace of grinding and schedule to improve. So what you want to get out of this, besides learning how to attack boxes and what that looks like, is getting this kind of mindset for security and thinking like an adversary. This program, the PWK, is definitely going to challenge you. It's going to force you to sort of bash your head against the wall for a while and really help you build that resiliency and problem solving and really troubleshooting. There's going to be challenges. You're going to have to learn new protocols. You're going to see things that, we just don't talk about, and you're going to have to figure out, what they are, what it's used for. You're going to go down rabbit holes, and, you're going to learn which rabbit holes are worth going down and which ones aren't. For the most part, right, as you're learning, all rabbit holes are worth going down because you're going to learn something from them, but not all of those rabbit holes will lead you to, rooting a particular box. And hopefully, rooting boxes or learning to attack them, this sort of cycle and sort of game will help you develop kind of a passion for the sort of technical side of cybersecurity. So after completing PWK, this is what they say, right? Offensive security says you should be able to do, right? You should be able to find and assess potential vulnerabilities, right? Look on something, find where the holes are in network security, in executable programs, inside protocols. So, right, at all different levels of the OSI model, you're finding vulnerabilities. We're going to look through the ethical issues with hacking and where you actually have the right to attack things. Like, when do you have permission to use some of these tools and some of these weapons? We're going to actually use tools and craft some exploits, right, by looking at other people's proof of concepts, right? They've found an exploit that works some way, and you're going to, decipher what that proof of concept is and use it for your own device. And you're going to understand basic techniques of how do people gain access, unauthorized access into systems, and how do people escalate those privileges, right? This is going to give you that mindset and like, what do the bad guys actually do? What are they looking for? So that when we flip that chessboard around, you'll be able to see the patterns of what the bad guys do, so you know what to look for to stop them. Cool. Questions so far? People hyped? Yeah. These are the objectives to get out of the next 4 weeks. Okay, so where does PWK fit in there? Right, so PWK is a course, right, by Offensive Security. Offensive Security is the folks that make Kali Linux, make a bunch of other tools too. And so we want to introduce you to a whole bunch of ethical hacking tools, what the techniques are, and walk you through this course that they have. I want to say there's more than 8 hours of videos now. The PDF, the giant textbook, is about 850 some odd pages. They're going to provide you with their own version of a Kali VM that they suggest you use on the network. It might have certain versions of things that they know will probably work better and make your experience a little bit better. So I suggest you use that one, and you'll get access to it to download. They'll also give you a private Windows 10 lab machine that you can connect to through remote desktop protocol. So, you'll see there's instructions inside the textbook and in video, but essentially you'll have a terminal open, you'll type in RDP, you'll give it the machine you want a remote desktop to, and then you'll have a little Windows machine in your VM. Right? And again, everything's going to be accessed through that VPN. And then the interactive part of it, where what we get access to, there's 35 public machines. So once we connect, there'll be, I think the numbers changed a little, might be a little bit more than that now, but about 35 machines that we'll be able to see directly. And another 15 or so, 20 or so machines on some subnets that you kind of have to do a little bit of work to get to. We're going to be spending almost all of our time on the public machines. So what do we need to know to like get success, to find value out of doing this course? Well, right, so all of the things that we've kind of been learning, right, since the beginning of this, since foundations and before. Right, you need to understand the OSI model so we understand the different areas that we're going to be attacking and looking for vulnerabilities. Right, we need to understand specifically IP addresses and port numbers, because a lot of communication is going to be happening over TCP/IP. We're going to have to understand how the different services work together, and like kind of, how they work together, and how they're used on an actual network where there's, more than one box. There's a few different things happening going on, right? So how does DNS function in a network, right? How is SSH used? How are the different web servers, and et cetera? What else do we need? We need to know Linux and Windows. We need to know how to navigate operating systems and move around different machines. So we need that command line experience, right? We need account administration, so we can find out what different users are on machines, right? Maybe we need to add a user so that we can ourselves get onto machines and have more privileges. We need to understand file permissions, so we understand what we can and cannot do, how we can bring our own tools over, how we can access different files we might not supposedly have access to, and how to interact with services, right? How to start them, stop them, maybe change configurations so that we can use them the way we want. And also, we'll have to learn scripting. Right, we're not going to be doing too much more scripting, right? The level of scripting is not going to get more challenging than we've already been, right? That like blackjack problem is probably about as hard as things will go. But you need to be familiar with some Bash scripting and some Python scripting. But that is all kind of a vehicle so that you can understand other languages. Not so much so you can write other languages, but so that you can kind of read them and get an idea for what's going on, how the data is flowing, right? If you change one variable, is that going to change other things, right? So right, the Bash and the Python are kind of the vehicle for understanding programming in general, because that's kind of a requirement, right? It's one of these knowledge requirements for all of this. And eventually, towards the end of the program, you're going to need to access and find success on the buffer overflow attacks, some understanding of assembly and machine code. We'll get to that part, right? That's bold. That's like new stuff that we haven't even started to get into. Any questions so far? How's all of this stuff look like? Stuff we've kind of, at least are familiar with? It's thumbs up, not thumbs up. We're feeling beaten up by the test. Yeah, okay, cool. We've seen these things before. Okay, so what does the lab environment look like? Right, so at the bottom cloud, that network right there, that's the student labs, that's the public network. As soon as we connect, right, as soon as we do that open VPN, give it your connection pack and authenticate, that's where we're going to be. We're going to get an IP address assigned to those student labs public network. And that's going to be where we're spending most of our time. You'll also notice there's a development network, an IT network, and the administrative department. And between them, you have some firewalls. So you're going to have to figure out some way to get access to those networks. There's firewalls in between. We'll get there. But just so you have a kind of mental map in your mind to think of, this is what we're looking at. Okay, spending most of our time in those student labs. So what does that look like? Another diagram here, right? You are a student in the top cloud normally, right? That would be us kind of together. But we're not together now. We're all in our own little clouds connecting to that VPN into the private labs, right? And inside that network, inside the PWK main lab and network, that's, I think they call it the student network. We'll see a whole bunch of different workstations, and I do believe they're all still 10.11.1. So everything is going to be off of that subnet, right? So we remember we hit 10.11.1.220. Yeah, it must have been that. So all the machines off there will be 10.11.1. something. All right, so we'll find a machine that's the mail server. We'll find some people's random workstations, right? We'll find the DNS server, right? Other different kinds of machines, and maybe getting access to one machine might give you more information to another machine, right? It all depends. It's kind of all interconnected here, and it's really kind of understanding and mapping a interconnected network. Cool stuff, cool stuff. So PWK is going to be doing most of the labs. We're actually pretty lucky. My understanding is this time, so like I said, the labs in the textbook, I'll show you some examples of it. It's like, just like imagine exercises that you would normally see in any kind of textbook, like a math textbook or like a science textbook sort of thing. They're like, do these things, right? Do DNS enumeration on this machine or something like that. That is how they'll give it to you in the textbook. I think Offensive Security has given us access to this this program called PTAP. And the way you can imagine it is that what's that?
That's not confirmed yet.
Not confirmed yet? All right, so don't even worry about PTAP. It's going to be exercises like this where, well, let's give you an example. This is pulled right out of this. I think this is the older version of the textbook. But like, this is what one of those exercises might look like. It's something similar to something we've already done before. I think we may have actually already done this before, right? So understanding bash loops, and write a short script to perform a ping sweep of your current subnet. And then do it in a scripting language, right? Perl or Ruby or Python. And then, right, just gives you a little tip right there with number 3. So if you were to provide some proof of work, this is what would be a proof of work for that. You have a screenshot right there, running a ping sweep of that 10.11.1 network. Right. So what's the point of doing these exercises other than learning? If you do all of the exercises that say they're required, you submit proof just like this, you'll get an extra 5 points when you take your OSCP attempt, which could be, could be the difference between passing and failing. And, you should do these exercises to learn anyway, because all of these exercises map to a situation on the network. So if you just are very diligent and as you're doing them, document everything, you will, get 5 extra points for doing your work. Here's another example. Update your proof of concept so you have control of VIP register. This is an example talking about buffer overflow, so not going to make too much sense to you right now, right? And identify what characters you can use as your payload, or update your proof of concept to obtain a shell from Crossfire, right? So they're asking you to update someone else's code, right? So this might be a solution right there. So this is just some Python code. I know it looks scary, but it's because there's a whole bunch of hex characters in it. But if it's just a bunch of hex characters in a string, it's not very scary. It's not doing too much. It's adding them together and throwing them through a socket. But this would be an acceptable solution to this, right? It's just, here's some code, we want it, right? They just need a screenshot of what it is that you did that satisfies the exercise. Doesn't need to make sense to you right now. I'm just telling you the level of detail that you have to have. A screenshot will generally suffice if it has everything. Okay, cool. So stop there.